Hello. So today let's solve some math problems over rational expressions. And whenever we talk about rational expressions, sometimes they can become overwhelming just at the first look. What I like to do is acknowledge what's going on here. My first thing is acknowledge that I have a division, and in this division I have fractions. So we know there's a rule that we have to follow with that. Also notice that in the numerator here, I have a fraction plus a fraction. Well, there's a whole set of rules with adding or subtraction of fractions. So let's clean that mess up before we start going any further. So what I'm going to do is I'm just going to rewrite the numerator one more time. And I want to clean this up. In order to clean this up or add or subtract fractions, I need to apply the rule for that. And the rule is whenever you add or subtract fractions, you have to have the least common denominator. I also noticed that in my denominator, I have a prime number and it's 3, and I have a prime number that's 7. Whenever I have a prime number in the denominator, if I multiply them together, I automatically find my least common denominator. It makes it so much easier. So what I'm going to do is I'm going to acknowledge what my GCF here is, my common denominator is. Uh, sorry, it's a GCF, my GCD, my common denominator. So whenever I figure out what that is, I'm going to say 3 times 7, which is 21. So my common denominator here is 21. And what I'm going to do is multiply each fraction by the missing piece. So this fraction has 3 in the denominator, so I'm going to multiply by 7. Whatever we do to the bottom, though, we must do to the top. I notice this next one here has got 7 in the denominator, so I'm going to multiply the bottom by 3. But again, whatever I did to the bottom, I have to do to the top. So let's do this. I got 7 times 2x is 14x. And then, of course, 7 times 3 is 21. But I'm going to write it all over that denominator. And now I got 4x times 3, which is 12x. All right. I noticed that I have x to the first power here and x to the first power here. So I can put those two together using the addition. So I have 14 plus 12, which is 26x over 21. My first thing is I'll need to reduce if possible, but I noticed the 26 is a product of 2 and 13. 21, we know is 3 and 7, so it don't reduce. So now let's move on. Let's move on to the rule of division with fractions. So this rule of division with at least one fraction is we're going to keep the first term, change division to multiplication, and flip the second. So let's plot. My numerator is 26x, and that's my first term. I'm keeping the same. I'm going to change division to multiplication, and then I'm going to flip my second, and it's x over 2, so it becomes 2 over x. So now let's go through here and clean this up. I notice again in my numerator is 26x and 2. Whenever you have multiply fractions, we always reduce topmost to bottom. If you want to multiply all the way out and then reduce, that's fine, but I like working with numbers as small as possible. So when I look at the numbers, 26 is 2s and 13s, and then I got another 2. The denominator is still 3 and 7, so I can't reduce that. So the numbers stay the same. So now I got 26 times 2, which gives me, let's see, 2 times 6 is 12, carry the 1, 54. I mean 52, sorry, I said 54, 52. But I notice here I have x in the numerator and x in the denominator. Whenever we divide by these x's, we ask ourselves how many times will x here go into that x? Well, they go into themselves once because they have a power of 1. So my x is reduced and I'm left with an answer of 52. Thank you.